students, welcome to the next video of application of derivative. In today's video we are going to see how to find the maxima and minima. Okay, so let's see what this maxima and minima means. So first we have to find the f dash x and f double dash x. Okay, means first order derivative and second order derivative. Okay, now if f dash x is equal to 0 means first order derivative is 0 and f double dash x second order derivative is negative less than 0 at any point x equal to a, then f of x is maximum. Okay, condition for maxima is if second order derivative is negative means less than 0. So if we are getting second order derivative as less than 0 or negative, then we get a maximum value or maxima at f a. Okay, then if f dash x equal to 0 means first order derivative is 0 and second order derivative is greater than 0 means positive at x equal to a, then f of x will be a minimum at f of a. Okay, so maximum value and minimum value, for that what we have to do, we have to first find first order derivative and second order derivative. Then we have to check the condition. If f double dash x is less than 0, then we get a maxima. And if double dash x is greater than 0, means second order derivative is positive, then we get a minima. Okay, or minimum value. So see case 1. In case 1, f dash x changes sign from positive to negative at x equal to a, that is f dash x is greater than 0 for x is less than a and f dash x is less than 0 for x greater than a. Okay, then f of x has a local maximum value at x equal to a. Okay, so when x equal to a, then we get a maximum value. Here opposite of case 1. So if f dash x changes sign from negative to positive at x equal to a, that is f dash x is less than 0 for x less than a and f dash 0 is greater than 0 for x greater than 0, then f of x has a local minimum value at x equal to a. Okay, so we are interested in finding this maximum and minimum values. Now see the example. So question is find the maximum and minimum value of x cube minus 12x minus 5. Okay, so first we have to differentiate this y with respect to x. So dy upon dx, derivative of x cube, derivative of x cube is 3x square, then minus derivative of 12x is 12. 3 is common, so we'll get x square minus 4. X square minus 4 means x plus 2, x minus 2. Okay, so for maximum and minimum value of y is equal to f of x, what we have to do, we have to put first order equal to 0. Now we'll put dy upon dx as 0. So dy upon dx means this 3 into x plus 2 into x minus 2 equal to 0. Okay, so that means x plus 2 equal to 0 or x minus 2 equal to 0. So either x equal to minus 2 or x equal to 2. Okay, so we got the value for x. Now see this step. Let me clear this. Okay, now see dy upon dx is 3x square minus 12. So from this we differentiate this dy upon dx again with respect to x and we get the second derivative, second order derivative means d2y upon dx square as 3 as it is, derivative of x square will be 2x minus derivative of 12 0. So that is equal to 6x. Okay, so second order derivative is 6x. Okay, now at x equal to minus 2, d2y upon dx square, that will be 6 into minus 2, so minus 12. Okay, so when x equal to minus 12, sorry, we are getting second order derivative as minus 12, which is less than 0. So x equal to minus 2 will give the maximum value, because second order derivative is negative. Negative means we get the maximum value. So x equal to minus 2 will give the maximum value. Okay, now let us find the maximum value. So we substitute minus 2 in given equation, in this equation. So that will be minus 2 whole cube minus 12 into minus 2 minus 5. So that is equal to 11. Okay, so see, point of maximum is minus 2. When x is minus 2, y will be 11. Okay, now let's substitute the other value of x. So other value is 2. So x equal to 2. By substituting in d2y upon dx square, we get 6 into 2. So plus 12. Right? So positive means we get a minimum value when we substitute x as 2. So now we are going to substitute 2 in this equation. So when x equal to 2, then y minimum is minus 21. So minimum point is 2 minus 21. Okay, so this is the method of finding maximum and minimum value. So for maximum or minimum, what we have to do? First step is we have to find first order derivative and second order derivative. Okay, then in second step we have to put first order derivative, means dy upon dx equal to 0, and solve the equation and find the values for x. Then next step is substitute that x value in second order derivative and check the condition whether we are getting positive or negative. Okay, so positive, if second order derivative is positive, that means we get a minimum value. Okay, the minimum value of y. And when we get a negative second order derivative, means d2y upon dx square is negative, less than 0, then by substituting x we get maximum value for y. Okay, see one more example. Okay, so the other example is, see here, question is here, find the maximum and minimum value of x square minus 18x square plus 96x. Okay, so first step is find dy upon dx. So dy upon dx is 3x square minus 36x plus 96. Okay, then 3 common, so we get x square minus 12x plus 32. Okay, now by factorizing this quadratic equation we get 3 into x minus 8 into x minus 4. That means x values are 8 and 4. Okay, by putting this dy upon dx equal to 0, we get x equal to 8 or x equal to 4. Now let's see the second order derivative. So this is the first order derivative. So second order derivative will be 3 as it is, derivative of x square is 2x. So 6x minus 36. Okay. Now when x equal to 4, then second order derivative will be 6 into 4 minus 36. So minus 12. Okay. That is less than 0. Okay. Again I am getting second order derivative as minus 12. Okay. But that is purely coincidence. Okay. Not every time you will get same value. So second order derivative is minus 12 means negative. So we get a maximum value. So let's find the y maximum. Y maximum will be, we substitute x as 4 in this equation. So we get y maximum as 160. Okay, so maximum point is 4, 160. Now when x equal to 8, then second order derivative is plus 12, which is greater than 0, and hence we get the minimum value, and y minimum will be 128, and so the point is 8 and 128. Okay. Now see the third example. Third example is divide 80 into two parts such that their product is maximum. Okay. Now I am going to divide this 80 into two parts. Now let the first part is x. Okay. And if the first part, I am dividing this 80 into two parts. So if the first part is x, then the other part will be 80 minus x. Okay. Now there is a condition. Condition is what? Their product should be maximum. Product means multiplication. So that means x into 80 minus x. Okay. So here p, or I can say y. Y is x into 80 minus x. That is the equation. So first, in word problem, first step is to form a equation. So here what I am getting, y is equal to x into 80 minus x. Okay. Now differentiate this. So before differentiating, let me multiply this. So I will get 80x minus x square. So derivative will be dy upon dx will be derivative of 80x is 80 minus derivative of x square is 2x. Okay. Now we'll take 2 common. So what I am getting, 40 minus x. Now let this dy upon dx equal to 0. That means 2 into 40 minus x equal to 0. That means x equal to 40. Okay. Now let us find the second order derivative. So this is the first order derivative. Again I am differentiating this first order derivative with respect to x. So I will get d2y upon dx square, that is equal to derivative of 80 0 minus derivative of 2x 2. So answer is minus 2. Okay. Now since this is negative, right, less than 0, second order derivative is negative, and hence we get a maximum value. So x equal to 40 will give the maximum product. So first part is 40 and the other part is 80 minus x means 40. So 40 will give the maximum product. Okay. So similar type of sum. Here what is given, divide 20 into two parts such that the product of one and cube of the other is maximum. Okay. So 20 into two parts. One part is x, the other part will be, we have to divide. We have to divide 20 into two parts. One part is x, then other part will be 20 minus x. Okay. So question is what? Divide this in such that the product of one and cube of other is maximum. Okay. So equation is y is equal to 20 minus x into x cube. Okay. So that is equal to 20x cube minus x raised to 4. So differentiating with respect to x, so we get 60x square minus 4x cube. So 4x square common, so 15 minus x. Now put dy upon dx equal to 0. So we get 4x square into 15 minus x equal to 0. That means either x equal to 0 or x equal to 15. So x equal to 0 is not possible. So we'll drop this value and we'll take the other value for x. So now x is equal to 15. So if x equal to 15, then see, x is given as 15. Now we have to find the second order derivative. So second order derivative will be 120 into 12x square, right? So 120x minus 12x square. So that means 1800 minus 2700. So that is equal to minus 900, which is definitely less than 0. Hence x equal to 15 will give the maximum product. Okay. So the first part is x equal to 15. Okay. So first part is 15 and the other part will be 20 minus x means 5. So two parts of 20 will be 5 and 15. Okay. Then with this I am concluding this video. Thank you students.